In this video, we're going to discuss randomized blocks. So what does that mean? You've got two factors influencing a dependent variable. So you might want to predict sales, and price and advertising affect sales. You might want to predict sales, and the territory and the salesperson affect the sales during a particular month. You might work for a drug company, and the yield of a production process may be influenced by temperature and pressure. And so you want to easily figure out how these two factors affect what you're trying to predict. So let's focus on the second example here. So we have 5 sales districts and 4 representatives. So basically, we had District 1, we'll try each representative and assume the weeks are basically the similar, and that one week isn't supposed to have higher sales than the other week. That would be a third factor. Then we ran each sales rep through District 2, each sales rep through District 3 one week, each sales rep through District 4, and each sales rep through District 5. So the question is, do the districts differ significantly in sales, and do the representatives differ significantly in sales, and how can we predict sales that a representative might make in a particular district? Now here we have only one data point for each combination of district and representative. Ideally, we'd like to have more, and we'll get to that a little bit later. But when you have one data point for each combination of the two factors, you use what's called randomized blocks. So trying to figure out who's the best salesperson, you should block for the effect of the district, okay? Because if you gave a certain representative the best district all the time, they would sell more, okay? So, and you should really make these sort of be random. They have chance to determine the time order of these. In other words, representative 1 shouldn't have always been the first in each district. I mean, you should sort of flip a coin or use some random number generator to block out the influence of time, but we're not going to worry about that. Okay, so we go to data analysis add-in. Okay, we just use that in one-way ANOVA. It's two-way factor without replication, but most stat books call that randomized blocks. So the input range would be right here. I've got labels, and we leave this alpha at 5%. It just doesn't matter. And so then we would go here. We can just put it anywhere. Okay, so there's our output. Okay, so now the question is, what do we have here? What does it tell us? Well, we have the mean effects. Okay, we have the overall mean. If we just average all these, average everything for our data points, or just average the averages, it doesn't matter. So the average is, I think, 17.6, okay? So on the average 17.6 100 units, or whatever we want to call it, were sold. And then we want to know what are the effects for each district and each representative. So we take this average here minus this. So this would be E15. Again, when I use the F4 trick on this computer, sometimes makes the microphone go off, and we don't want that. So we'd have effect of minus 11.1. So District 1 is not a very good district, okay? But basically District 5 is really good. It's 10.4 above average. And now we could copy this formula down here to get the effects of the salespeople. Now the question is, are these effects significant? And there you just go to your p-values again. So rows is going to be the district, and the salesperson are columns. So you look and see, are your p-values less than 0.05? So the p-values for a row and column each less than 0.05. So district and salesperson have a significant effect on sales. Okay. Now it might be that just the district had a significant effect and just the person. And now the standard deviation of our forecast, when we forecast, let's say what we'd sell, as an example, we're going to do District 2, Rep 4. We'll try and predict what we might sell. Nice movie, District 9, I remember. Okay, so what would the sales be? We'll get to that in a minute. But it's, again, the square root of the mean squared error that we discussed before is going to be your standard deviation. That's about 3.99 there. Okay, so now your best forecast for District 2, Rep 4, is you'd start with the overall average. And then since it's District 2, you'd knock it down by 2.85. And at Sales Rep 4, you'd raise it by 3.6. So you would get there 18.35. And then if you want to lower an upper limit, you would take 18.35 minus 2 times that 3.99. So that would be 10.37. And the upper limit, you'd go 2 standard errors or standard deviations above, plus 2 times this. So you're 95% sure if this is 100, you'd sell between 1,037 and 2633 on a week in which you had District 2 in Rep 4 selling in District 2. Now again, if only the row effect was important, you wouldn't adjust by the person effect. Okay, you would just use the district effect. And if only the person effect was important, you wouldn't adjust based on the district. So now in our next few videos, we'll talk about where you have more than one observation for each combination of the two factors, because then you can test for what's called interaction. Do the effects of the two, does the value of one factor affect the value of the other? See here, we have no way to determine like if the district would have a different effect on representative, if District 1, for instance, had a different effect on Representative 2 than it had on Representative 1. We just have to separate out these additive effects.
Okay, so thanks for watching, and there's a free course, a free 21-day course from Dr. Winston, and all of these videos are coming from one of 3 books. So first, this one, which you can see here at the top of the screen, Microsoft's book, which has 355 reviews, and then it's, let's see, 4.6 stars. It's coming from this book as well, his marketing analytics book, which is down here, and you can sort of see 4.5, or his newest book, his analytic stories book, which is here. And with that one, you can see it's 4 point something, or maybe even 5. I don't think it's 5. Yeah, 4.8. And so yeah, anyways, in the description, there's a free 21-day course from Dr. Winston, or you can go to excelwithwayne.com/free, and it'll be there. But again, thanks for watching, and if you have any questions, just please let us know. Thanks.